For this question, it says to use the substitution formula to evaluate the integrals. And the first one is the integral from 0 to 7 of the square root of y plus 9 dy. And the second one is the integral from -8 to 0 of the square root of y plus 9 dy. I'm going to show you two ways to think about it. They both end up being the same thing in the end, but it's just two different ways to come at doing definite integrals when you have to use the substitution method. So one way to think about it is, let's first think about just the indefinite integral of the square root of that y plus 9 dy. So for substitution, let's let u equal to the y plus 9. That's the function within the other function. It's a function within the square root function. So our du, well, take the derivative of the y plus 9. That'll be just what? 1 dy. So du would just be the dy. So substitute that in to this indefinite integral. We would get the integral of the square root of u du, which would be the same thing as this integral of u to the 1/2 du. And we know that by using the power rule for integration. So you add 1 to the exponent, divide by that exponent, and dividing by, in this case, 3/2 is the same thing as multiplying by 2/3. So we'd have 2/3 u to the 3/2, and then plus c, because this is an indefinite integral. And then substituting back in the y plus 9 in for the u, we'd have the 2/3 the y plus 9 to the 3/2 plus c. And then when we think about it back with the definite integral, so that the integral from 0 to 7 of the square root of y plus 9 dy will equal to, now evaluating our antiderivative, except we could ignore the plus c, because if it's plus some constant, when you plug in the upper limit and then minus the lower limit, the constant would just cancel each other out. So it would just be the 2/3 y, the quantity y plus 9 to the 3/2 evaluated from that 0 to 7. So plugging in that 7, we'd have, let's see, 2/3. Let's see, the y 7 plus 9, that'll be what, 16 to the 3/2 minus 2/3. Plugging in the 0, 0 plus 9 would be 9, so it'd be 9 to the 3/2, which is, well, let's see, 16 to the 3/2, that'd be the same thing as the square root of 16 cubed. So the square root of 16 would be 4, and cubed would be 64, so we'd have 2/3 times 64 minus, and then 9 to the 3/2 would be the same thing as the square root of 9 cubed, so that would be 3 cubed, so that would be 27. So this would be, well, this should have been 2, I don't know why I wrote 3 over 64, that was 2/3. Don't ask me where that came from. So 2/3 times that 64, and then minus 2/3 times, like I was saying, the 9 to the 3/2, that would be 27. And let's just see, so this will be 2/3 times 64, well, that would be 128 all over 3 minus, no, you can simplify this, but since we want to subtract and we want to keep the common denominator 3, this would be minus 54 over 3. And then 128 minus 54, that would be 74 over 3. Let's see. Check the answer. And nice work. Now let's do it from the 0 to -8. Now we could just plug in, it could be our -8 to 0, so we could plug in -8 for our lower limit and 0 for our upper limit. But what I want to do, instead of doing that, let's pretend if we were doing a whole new problem, and it wasn't actually the same antiderivative. Now another way to do this is, if we're doing this integral from negative 8 to 0 y square root of y plus 9 dy, again we would let u equal to that y plus 9, so the du would again be the dy. But now if we also change the limits of integration, well, before we were going from y going from negative 8 to 0, now if, let's see, so when y is 0, that would correspond to, well, let's see, if we plug in y equal to 0, that would be when u is 9. And for our lower limit, when y was negative 8, plugging in negative 8 for y, that'll be negative 8 plus 9, so that'll be 1. So u would be 1. So the integral of from negative 8 to 0, the square root of y plus 9 dy would be the same thing as the integral from 1 to 9 of the square root of u du. So that would be, again, like we're saying, the integral of the square root of u, that would be, 2/3 u to the 3/2 from 1 to 9. Then plugging in these limits, so that would be 2/3, plugging in 9, so that would be 9 to the 3/2 minus 2/3, 1 to the 3/2. Now you would have got the same thing if you would have did just like what we did before, and plug in the negative 8 and the 0 in for the y. When you substitute back in the y plus 9 for the u, and you would have got the same thing. This is just another way you can think about doing it. Now, as we said before, so it'd be what, 2/3, 9 to the 3/2, we said that was 27, minus, well, 1 to the 3/2, 1, so this will be just minus 2/3. So this would be what, 54 over 3 minus 2/3, so that would be 52 over 3. So checking our answer. And again, fantastic. So again, that's two different ways. You get the same answer either way, and they're not really different. It's just a different viewpoint of it in terms of the y or the u's. But like I said, you get the same answer in the end either way.